Good morning, students. So in Canada, we are going to start with one very important and interesting topic of mechanics. This is also the last chapter of mechanics. So what is it? System of particles and rotational motion. நீங்கள் ஒரு சில நீட் டெக்ஸ்ட் புக்ஸில் பார்த்தா they will give it as like two separate chapters. ரெண்டு தனித்தனியாக system of particles தனியாக வரும், அந்த மாதிரி rotation motion will be given separately. But NCERT wise என்னன்னா this is like a single chapter மாதிரி தான். Okay, so அதனால we will also try to cover it like a single chapter, but we will anyway cover both the things separately. Okay, so இந்த chapterல இருந்து என்னன்னா we will be able to get கண்டிப்பா definitely two questions. There will be a scope of getting from this chapter. Maybe sometimes we can get more number of questions also. Okay, then a system of particles and center of mass, right? Adu tani concept. Adukapra rotational motion is a different concept. So maximum if you look at the past year NEET papers, right, adilende you will get one question, system of particles and center of motion, other applications lande and madri we will also get a question from the rotational motion part. Okay va? So we will start the discussion. First we will try to understand what is this system of particles. See, normally idukku munadi nama Newton's laws of motion chapter agatum or the work energy power, right? Remember, so what is the thing, whenever we talk about an object or a body and so on, we said we will assume the concept of point mass and solidity. So we'll assume the concept of point mass. Point mass and it will be located at a single point. Okay va? But normally we will not have a point mass, right? One particle mattum irukadu. You will be having what, like if you have, say for example, ஒரு 3 பாயிண்ட் மாஸ் இருக்கா, இல்லைனா 4 பாயிண்ட் மாசஸ், இல்லைனா 5 பாயிண்ட் மாசஸ், இந்த மாதிரி. ஸோ லைக் ஃபார் எக்ஸாம்பிள் M1 இங்கே இருக்கா, M2, M3, M4, M5. ஓகேவா? ஸோ இப்படி இருந்தால் லைக் யூ ஹாவ் தி பார்ட்டிகல்ஸ் ஆன் சொல்லலாம் ஆர் த பாயிண்ட் மாசஸ் விச் ஆர் கவுண்டபிள் ஆர் டிஸ்கிரீட். இங்கே பாருங்க, ஸோ கவுண்டபிள் ஆர் டிஸ்கிரீட் அப்படி ஒரு configuration சொல்லலாம் or the arrangement னு சொல்லலாம். Okay, if that is what we are studying, இதுதான் நம்ம ஸ்டடி பண்ண போறோம்னா this is what we will be referring to as a system of particles னு சொல்லுவோம். So என்னது? So normally when we say object or a body னு சொன்னா that is what we are considering as a single point mass. அப்படி இல்லாம if we are required to study a group of discrete particles, okay va? So adukku nama enna, what is the name that we give for this system of particles and solo. Okay va? But if you are having an extended body, so neenga or extended body edutha vechukonga. What is extended body? Like anything like this pen is also extended body dana. Like anything that you see around you as what, extended body. Adula enna theriyuma? So parunga, let's say I am talking about only this particular pen. Okay, so inga parunga, this has got how many number of such particles? Ithina particles irukum. You can அப்படியே you keep on dividing, right? How many particles will be there? Theoretically ithina varum, infinite number of particles ana. So if you keep on breaking the pen into small particles, ithina particles varum, infinite number of particles varum. Okay va? So extended body and sonna, or a large body, whatever we take, or a practical object, that is going to have infinite number of particles. அதை நம்மளால கவுண்ட் பண்ண முடியாது. ஓகேவா? ஸோ when we are talking about system of particles சொன்னா what is it that we are referring to? ஒரு discrete countable number of particles. அதுக்கு தான் நம்ம system of particles சொல்லுவோம். ஓகே, ஸோ இது இந்த சாப்டர் என்னன்னா we are going to study the motion of system of particles நம்ம கவர் பண்ண போறோம். அந்த மாதிரி we are also going to cover the motion of the extended bodies. Okay, we are going to cover the motion of system of particles, and the madri we are also going to cover the motion of the extended bodies. Extended body and sonna adula, what is the difference between system of particles and solradhukku or extended body, adukku rendukku what is the difference between them? System of particles and sonna, this is what we generally refer to as countable, like 2 particles agatum, 3 particles agatum, 4 5 and madri countable. Even 1 lakh is countable, 1 crore also is countable. Okay va? When we say extended body, it is like infinite number of particles will be there on it. Okay va? But extended bodies enna theriyuma? So look at these two extended bodies. Inga parunga, idana the left side la irukka the rock. அது ஒரு எக்ஸ்டெண்டட் பாடி தானா? அந்த ரைட் சைடில் என்ன இருக்கா? we are having a rubber band. அது என்னது? அதே ஒரு எக்ஸ்டெண்டட் பாடி தான். பட் ரெண்டுத்துக்கும் டிஃபரன்ஸ் என்ன பாருங்க. வாட் இஸ் த டிஃபரன்ஸ் பிட்வீன் a rock and a rubber band? நீங்க ராக் எடுத்துட்டு அதை நம்ம டிஃபார்ம் பண்ண முடியாது. ஸோ ராக் ரைட் cannot be deformed. ஸோ நீங்கள் ஒரு ராக் எடுத்துட்டு அதை டிஃபார்ம் பண்ண முடியாது. பட் இங்க பாருங்க ரப்பர் பேண்ட் ரைட் அப்படியே நம்ம எலாங்கேட் பண்ணலாம். ஸோ ஈவன் இன் ப்ராப்பர்ட்டிஸ் ஆஃப் சாலிட்ஸ் ரைட் நம்ம இதை பற்றி படிக்க போகிறோம். லைக் யூனோ வில் டாக் அபவுட் கேரக்டரிஸ்டிக் எலாஸ்டோமர்ஸ்ன்னு சொல்லுவோம். ஓகேவா? ஸோ வாட் இஸ் திஸ்? திஸ் வில் ஹாவ் த ப்ராப்பர்ட்டி டு elongate. Okay, so when you look at the difference between a rock and a rubber band, right? So what is the difference? Main difference in the rock cannot be deformed, but the rubber band can be easily deformed. Deformed and sonna what we see from outside la nama paakradhu enna adoda shape change agum, size change agum, adana deformation and sonna what is the quick namakku enna quick enna varum recall ku what is it that you are going to get? And the object oda shape change agum illana size change agum. But inga enna theriyuma, we are in the mechanics part, we are in the motion. Okay, so shape or size changing, right? Adu nama we will try to cover this in the properties of solids. But here when we look at the difference between a rigid body and an elastic object, inga enna theriyuma, what is the main difference that we will see? Rigid body kulla, let us say for example நம்ம ஒரு சில பாயிண்ட்ஸ் மார்க் பண்ணலாம், m1 m2 அந்த மாதிரி. ஓகேவா? நம்ம அப்படி பாயிண்ட்ஸ் மார்க் பண்ணா the distance between these two points m1 m3 ஆகட்டும் or m1 m2 ஆகட்டும் or m2 m4 like that, you take any two points and look at the distance between them. On the distance change ஆகும். ஓகேவா? so the distance between the particles of that extended body, ஏன்னா இதே ஒரு extended body தான், rubber is also extended body. நீங்க ஒரு rigid body, so இதுக்கு என்ன தெரியுமா, we are going to call it as a rigid body. So an object which cannot be deformed is called as what? Rigid body. Rigid body என்ன, the distance between the particles of the body will not be changing, அதோட வேல்யூ சேஞ்ச் ஆகாது. பட் இங்க என்ன தெரியுமா, in case of an elastic body, so this is what we call as generally the elastic body and சொல்லுவோம். So in case of an elastic body, right, பாருங்க, if you are elongating the rubber, அந்த rubber band எடுத்து நம்ம elongate பண்ண வெச்சுக்கோங்க, then what we are going to see, the distance, பாருங்க, let's say we will mark the points m1 m2 அந்த மாதிரி, the distance between the point masses of the body can change. Okay va? So when we go to talk about the rigid body motion, we will see why at least நம்ம பர்வியூல என்ன தெரியுமா, we don't study the motion of the elastic bodies. ஏன்னா அது கொஞ்சம் complicated ஆகும், because the particle ஓட the distance will keep on changing. So அதனால the study of the overall object ஓட motion, right, will become little bit more complicated. அதனால என்ன, we will try to focus mostly on the rigid body motion. Okay va? So we will try to focus mostly on what? Rigid body motion. Even rotational motion என்ன தெரியுமா, in our syllabus நமக்கு என்ன இருக்கா, we are having only the rotational motion of the rigid body. Okay, so rotational motion என்னன்னு சொல்லிட்டு we will try to cover it later. But in our syllabus என்னன்னா, we have only the rotational motion of the rigid body. So rigid body ஓட significance என்ன, the distance between the particles on that extended body will not be changing. ஏன்னா, because the object is not undergoing deformation, right? Deformation சொன்னா either it is getting compressed ஆகலாம் or it can be elongated. Okay, அது நடக்கலன்னா what it means, if you mark any points on that object, right, the distance between the points of that object will not be changing. Okay va? So this is what is the significance of the rigid body. Okay, so நமக்கு என்னன்னா, we have the study of motion of system of particles, and the மாதிரி we also have the study of motion of the rigid body. Study of motion of elastic body, it is not there in our syllabus. ஏன்னா it will get little bit more complicated. Okay va? அது எப்படி காம்ப்ளிகேட் ஆகும்னு சொல்லிட்டு we will try to understand once we go and discuss about the rigid body motion, right? Appo we will try to again take a look at the elastic body. Okay va? So this is about what we are going to cover. So main we are going to look at the system of particles or motion அந்த மாதிரி rigid body motion. So rigid body motion என்னன்னா so far நம்ம நியூட்டன்ஸ் லாஸ் ஆகட்டும் or the work energy theorem அதுல we are been talking about only one type of motion which is the translation motion. ஓகேவா? So இங்க என்னன்னா we also try to talk about another type of motion which is called as the rotational motion. Okay, so first we are going to look at the system of particles. அது முடிச்சிட்டு we will go to the discussion about the rotation motion. Okay, so அதனால என்ன I am not giving the definition of what is the rotational motion here. Okay, so first we will try to look at the system of particles concept. So system of particles என்னன்னு தெரியுமா? For system of particles, whether we talk about discrete system ன்னு சொன்னது we will have countable number of particles. It may be 2, 3 like that. Okay, or we can even have an extended body. Extended bodies can also be called as what? Continuous body and solid. Extended body can be also called as what? Continuous body. Okay, so whether we have a discrete system of particles or extended body, right? நம்ம அதோட motion நம்ம ஸ்டடி பண்ணோம்னா, like say for example பாருங்க, you have particle m1, particle m2, particle m3, particle m4 அந்த மாதிரி. We talk about the discrete system of particles. Each and every particle can have a different type of motion. Okay, so m1 it can have some velocity, and the madri m2 can have some velocity, and the madri m3 can have some velocity, m4 can have some velocity, and the madri accelerations also, they can have different kinds of motion. But how do we represent the overall? So for system of particles and so on, simpler, and it's like a group of particles. Okay, so how do we overall ஒரு பார்ட்டிகல் நீங்க எடுத்து பார்த்தா that அதோட motion different இருக்கா, பட் நம்ம overall நம்ம motion of the group describe பண்ண வெச்சுக்கோங்க, that is described by using the concept of center of mass. So இங்கல இருந்து அந்த concept of center of mass வருது பாருங்க. So ஏன்னா because you have a system of particles. Okay, so if you look at ஒரு particle நீங்க observe பண்ணா it can have different types of motion, the velocity ஆகட்டும், acceleration அந்த மாதிரி. Okay, but if you want to study the group of particles as a whole, bulk நம்ம பார்த்துட்டு we want to understand as a whole how this entire group is moving, that can be understood by looking at the center of mass. If we are going to define something called as center of mass, the center of mass and சொல்லிட்டு we are going to define a point. Center of mass என்ன தெரியுமா? It's like a point. It is a theoretical point. It's a theoretical point. Okay, the benefit, and now what is the benefit of defining this center of mass point? If you want to study the motion of group of particles or system of particles, you can understand what is the overall motion. So another paranga, we can understand what is the overall motion of system of particles by studying the motion of the center of mass. Okay va? So after some time we will see ஏன் இப்படி relation வருதுன்னு சொல்லிட்டு we will try to see. Okay, so another we are saying if you are having a group of particles or system of particles, each and every particle may have some different kind of motion. ஒரு particle எடுத்து நம்ம தனித்தனியா ஸ்டடி பண்ண முடியாது. We want to study the overall group of particles as a whole. அப்படி நம்ம ஸ்டடி பண்ணோம்னா we will just have to study the motion of the center of mass. So center of mass என்னது? It's a theoretical point. அதை நம்ம இப்போ define பண்ண போறோம். ஓகேவா? So இதுல என்ன we have to understand எப்படி how do we define the center of mass. அதுக்கப்புறம் we have to see how the center of mass or motion is related to the motion of the overall group of particles. So என்ன பண்ண போறோம்? First we are going to see எப்படி இந்த center of mass நம்ம define பண்ண போறது. அதுக்கப்புறம் we will have to see how the center of mass or motion, right, will help us to understand the overall motion of the group of particles. Okay va? So what is this center of mass concept? So no matter it is what? It is the theoretical point, okay, which describes the overall motion of the system of particles. So which describes the overall motion of the system of particles or overall motion it is going to describe. Okay va? Epo when the total mass ன்னு சொன்னா இப்போ say for example நம்ம எடுத்த system of particles there are 3 mass இருக்குன்னு வெச்சுக்கோங்க, m1 plus m2 plus m3, அதுதான் total mass. If total mass is assumed to be present எங்க at the center of mass location, if the total mass is assumed to be present at the center of mass location. Okay, so center of mass generally we will call it as cm and solluvom, or no, we can also call it as in general some point p and solala. In our discussion, right, we are going to talk about center of mass quite often. Okay, so either we will represent this by the symbol capital C capital M, adu vechi nama represent பண்ணல, or we can represent it by using any point p அப்படி சொல்லலாம். Okay வா? So இது center of mass ஓட significance பாருங்க. So what is significance center of mass? இது ஒரு real point கிடையாது. It is not like center of mass and சொன்னா it is not like a point having a mass அந்த மாதிரி கிடையாது. இது it's a theoretical concept which is used to explain the overall motion of the system of particles. அதுதான் center of mass ஓட main objective. Okay வா? இப்போ when we assume that அந்த group of particles ஓட total mass, இப்போ அந்த group of particles எல்லாம் எடுத்துட்டு just replace this by ஒரே single mass வச்சு நம்ம replace பண்ண வெச்சுக்கோங்க. Where we have to keep this mass? At that center of mass location. எங்க அந்த center of mass location நம்ம ஐடென்டிஃபை பண்ண போறோம், அங்க நம்ம ஒரே பாயிண்ட் வச்சு நம்ம ரீப்ளேஸ் பண்ணா the movement of the center of mass right will give us the overall system of particles ஓட movement picture. அதுதான் basic concept of center of mass. Okay வா? So இப்போ என்னன்னா we are going to see எப்படி how we will find out. So first point என்ன, we should know how to locate the center of mass. The first point என்ன தெரியுமா, we should know how to locate the center of mass. Second point, we should see what is the significance of center of mass. Significance ன்னு சொன்னா எப்படி how the motion of the center of mass particle is related to the overall motion of the entire group. Okay, so அதை நம்ம பார்க்கணும். இங்க என்ன தெரியுமா, to locate the center of mass we will have two separate approach and கிடையாது. Like first we will see the center of mass locating for the discrete system of particles. Okay, so we will see how do we find out the center of mass for the discrete system of particles. அதுக்கப்புறம் we will see how we can find out the center of mass for the extended body. So extended body என்ன வெச்சுக்கோங்க, how to find the center of mass location for the extended body, அதையும் நம்ம பார்க்க போறோம். ஓகேவா? So first we are going to see how to locate the center of mass for the discrete system of particles. பாருங்க. So how do we locate the center of mass for the discrete system of particles? Discrete system of particles ன்னு சொன்னா we can have like countable number of particles. Let us say for example just we are having two particles வெச்சுக்கோங்க, m1 and m2. Okay, they will be present at some coordinate points. அப்படிதானா, like if you take the coordinate system எடுத்தா m1 may be having the coordinates x1, y1, z1. அந்த மாதிரி m2 may be having the coordinates x2, y2, z2 அப்படி. ஓகேவா? the x coordinate of the center of mass பாருங்க, it will be given by m1 x1 plus m2 x2 by m1 plus m2. அந்த மாதிரி y coordinate of center of mass, right, will be given by m1 y1 plus m2 y2 by m1 plus m2. அந்த மாதிரி z coordinate of center of mass, right, will be given by m1 z1 plus m2 z2 divided by m1 plus m2. இது எப்படி வருது தெரியுமா, how this is coming? Each of these அந்த masses ஓட respective coordinates, right, இப்போ m1 ஓட x coordinate என்னது, x1. பாருங்க, இது நம்ம எப்படி எழுதலாம், ஸ்ப்ளிட் பண்ணி எழுதலாம். look at this, m1 by m1 plus m2 into x1 அப்படிதானா? அந்த மாதிரி அடுத்த டேர்ம் என்ன, m2 by m1 plus m2 into x2. பாருங்க. so what is the significance of this approach? We are taking weighted average. என்ன தெரியுமா, simply what is it, weighted average of coordinates of the respective masses. So இப்போ ஒரு system of particles சொன்னா அதுல we are taking an example of two particles. Okay, so how are we getting center of mass location for these two particles? ஒரு பார்ட்டிகளோட respective coordinates, x coordinate and the மாதிரி y coordinate and the மாதிரி z coordinate. We are taking simply what? Weighted average of the coordinates. இந்த பாருங்க weighted average ன்னு சொன்னா என்னது? Particle 1 ஓட mass எவ்வளவு? m1. So what is the, what fraction of weight it is having? m1 by total mass எவ்வளவு? m1 plus m2 தானா? So அந்த m1 by m1 plus m2 வச்சிட்டு we are multiplying the x1. அந்த மாதிரி x2 is multiplied by what? m2 by m1 plus m2. Okay va? So இப்படிதான் each of these coordinates, right? We are taking the weighted average. Okay, so the weightage is based on what? Based on the respective mass of the particles. So the coordinates of the center of mass will be given by what? Weighted average. This is an important formula. It's a very straightforward, right? And they just அப்படியே நம்ம அந்த ஒரு பார்ட்டிகளோட மாஸ் எடுத்துட்டு we have to multiply by the respective coordinates. எல்லாம் sum பண்ணி divided by what? Total mass of the system of particles. அவ்வளவுதான். இப்போ இங்க நமக்கு 3 particles இருந்து வெச்சுக்கோங்க. What will be the formula we'll get? m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. அதுதான் center of mass ஓட x coordinate. Y coordinate என்ன ஆகும்? m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. அவ்வளவுதான். Like as you increase more number of particles means ஒரு term extra வந்துட்டே இருக்கும். ஓகேவா? So this is what is the method to find the center of mass location for the discrete set of particles. Okay va? So the center of mass coordinates are given by what? Weighted average of the coordinates of the respective particles or masses. Okay, the weighted average and so now the weightage is based upon what? Weightage is based upon the mass of the respective particles. Okay va? So this is how we are going to find the center of mass location for the discrete particles. இப்போ பாருங்க எந்த மாதிரி questions வரலாம். Even in past year NEET என்ன தெரியுமா? We got some straight questions like this. இப்படியே they can give us some system of particles கொடுத்துட்டு they will be asking us to find the center of mass ஓட location. இங்க பாருங்க, consider the following system of 4 particles having masses m1 m2 m3 m4 located at the corners of the square. Side length எவ்வளவு a? இங்க பாருங்க, m1 is at the origin, m2 is on the x-axis, m4 எங்க இருக்கா? y-axis, m3 is in the xy plane. Okay, so டக்குன்னு சொல்லுங்க, what will be the coordinates of that? We பார்த்தா like all the points are in the xy plane only. So இங்க z coordinate concept வராது. All the points are in the xy plane தானா? So z coordinate வராது. Okay, so இப்போ பாருங்க, m1 is at the origin, right? So that x coordinate value என்ன 0. அந்த மாதிரி y coordinate 0. m2 is on the x-axis. What is the side length of the square? A. So அதனால the x coordinate will be a, but y coordinate will be 0. Okay, m3 ஓட coordinates பாருங்க, it will be what? a comma a. அப்படிதானா? x coordinate எவ்வளவு? a, y coordinate அந்த மாதிரி a. m4 பாருங்க, on the y axis means x coordinate 0, y coordinate எவ்வளவு? a. ஓகேவா? So these are the coordinates of the respective masses. எப்படி, how do you find the center of mass ஓட x center of mass? m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 எப்படிதானா? divide by m1 plus m2 plus m3 plus m4. That's it, right? பாருங்க, what is it? m1 into x1 எவ்வளவு? 0. m2 into x2 எவ்வளவு? a plus m3 into a, m4 x coordinate 0 தானா? divide by m1 plus m2 plus m3 plus m4. பாருங்க, what is it? m2 plus m3 into a divide by m1 plus m2 plus m3 plus m4. அவ்வளவுதான். That's it. Just take the weighted average. அவ்வளவுதான். So what is weighted average? m1 x1 plus m2 x2 அந்த மாதிரி. அப்படி பாருங்க, what will be the y coordinate of that center of mass? ஏன்னா இங்க z coordinate வராது, because all the particles are in the xy plane தானா? So y coordinate எது என்ன வரும் பாருங்க. So y center of mass பாருங்க, what will be the y center of mass? m1 into y1. So m1 ஓட y coordinate 0, அந்த term வராது. m2 into இங்க என்ன y coordinate 3b 0, so that also will not come. So பாருங்க m3 into a வரும், ஏன்னா m3 ஓட y coordinate a. அந்த மாதிரி m4 into a divide by denominator என்ன m1 plus m2 plus m3 plus m4, அவ்வளவுதான். This is the y coordinate of the center of mass. Okay, so அப்படி we will get the x coordinate of the center of mass and then y coordinate of the center of mass. Okay va? So like this we can expect some straight questions based on the weighted average formula. The formula வச்சு அப்படியே we can get some straight questions. Okay, so இதுல என்ன we are seeing what only finding the x coordinate and y coordinate. Sometimes they can give us problems like this where in a maximum we will get symmetrical cases. Symmetrical case enna ipdi parunga, consider the 8 particles at the corners of the cube, side length a. Okay, so like they are giving us 8 particles which are kept at the corners of the cube, side length of the cube evla a. Find the coordinates of the center of mass. என்ன நம்ம find out பண்ணனும், we should find out the coordinates of the center of mass. இங்க என்ன தெரியுமா, how many particles are there, எத்தனை particles இருக்கா, 8 particles are there. அந்த மாதிரி how many coordinates we have to represent, we have to represent all the 3 coordinates. ஏன்னா because this is a cube, right, so it's a 3-dimensional arrangement. பாருங்க the arrangement of the particles, it will be what, 3-dimensional. So we'll have x coordinate, we'll have y coordinate, and the மாதிரி we'll also have the z coordinates. பாருங்க என்ன பண்ணனும், ஒரு particle எடுத்துட்டு we have to look at the x coordinate value of the particle first. அதுனா so இப்ப பாருங்க m1 நம்ம எடுத்து வெச்சுக்கோங்க, so we have to find out what is x1 value, அந்த மாதிரி what is y1, அந்த மாதிரி what is z1, அப்படிதானா. அதுக்கு அப்புறம் we have to find out what is the particle 2, அதோட x coordinate, y coordinate, z coordinate. பாருங்க எப்படி வரும்னு சொல்லிட்டு, so look at this. If you take the particle 1 m1, okay, so எங்க இருக்க particle m1, it is on the, பாருங்க where is the particle m1, it is on the y axis தானா, it is on the y axis. so y axis ன்னு சொன்ன உடனே அதோட x coordinate 0, அந்த மாதிரி z coordinate 0. what will be the y coordinate, because side length of the cube எவ்வளவு a, so y coordinate will be a. okay வா. அப்புறம் look at the m2. m2 is in the xy plane. okay, m2 எங்க இருக்கு, xy plane. so அதோட x coordinate will be a, ஏன்னா will come like this, right, x coordinate will be a, அந்த மாதிரி y coordinate also will be what, a. z coordinate 0 because it is on the xy plane. m3 பாருங்க, m3 எங்க இருக்கு, exactly on the x axis. so it'll have வெறும் x coordinate, y coordinate, z coordinate will be 0. okay வா. m4 பாருங்க, m4 is our origin, right, m4 என்னது origin தானா, means x coordinate எவ்வளவு 0, y coordinate 0, அந்த மாதிரி z coordinate is 0. m5 எங்க வருதுன்னு பாருங்க, m5 எங்க வருது, where is m5 coming, m5 is coming in the எங்க, it is coming in the zy plane ல வருது. பாருங்க where is m5 coming, it is coming in the zy or yz plane ல வருது. okay, so அதோட x coordinate மட்டும் will be 0, y coordinate is a, அந்த மாதிரி z coordinate is a. m6 பாருங்க, m6 எங்க இருக்க, point here. okay, so we have to move. we have to move எவ்வளவு, so we have to move a along the x axis, a along the y axis, அந்த மாதிரி a along the z axis. இங்க பாருங்க, so we have to move. இப்போ m6 நம்ம ரீச் பண்ண வெச்சுக்கோங்க, m6 நம்ம ரீச் பண்றதுக்கு இங்க பாருங்க, so we have to move a along the x axis, அந்த மாதிரி we have to move a along the y axis. அதுக்கு அப்புறம் we have to move a along the z axis. so x coordinate எவ்வளவு a, y coordinate எவ்வளவு a, z coordinate எவ்வளவு a. ஓகேவா. so அதுதான் m6 ஓட கோஆர்டினேட்ஸ். so அப்படி ஒரு பார்ட்டிகிளோட கோஆர்டினேட்ஸ் நம்ம ஃபர்ஸ்ட் எழுதணும். so ஏன் நம்ம இந்த ப்ராப்ளம் ப்ராக்டிஸ் பண்றோம்னா because this is a very standard question. இது என்ன தெரியுமா, it's a standard question. இதில் அப்படியே கொஞ்சம் நியூமெரிக்கல்ஸ் சேஞ்ச் பண்ணிட்டு we can expect some questions in the examination also. So adhanal we are trying to do the question by taking general numbers. Okay va? So we are looking at how many particles present. 8 particles present. Okay, at the coordinates of the cube and the group of particles at the center of mass location. Adha நம்ம find out பண்ணனும். பாருங்க m7 எங்க இருக்கா? It is in the xz plane மேல இருக்கா. So அதனால the y coordinate too it will be 0. It will have x coordinate இருக்கும், அந்த மாதிரி z coordinates. இங்க பாருங்க m7 நம்ம reach பண்றதுக்கு we should cover a distance a along the z axis and cover a distance a along the x axis. So x coordinate is a, அந்த மாதிரி z coordinate is a. ஓகேவா? இங்க பாருங்க m8 அது எங்க இருக்கா? m8 is exactly sitting on the z axis தானா? m8 எங்க இருக்கா? It's exactly sitting on the z axis. So which means அதோட x coordinate will be 0, அந்த மாதிரி y coordinate also 0. So நீங்க கேர்ஃபுல்லா பார்த்து you have to write down these things. இதுல ஒரே ஒரு scope of making mistake என்ன தெரியுமா? நம்ம அந்த coordinate locations தப்பா எழுதுனா அங்கதான் we will spoil the problem. இல்லைன்னா once you are able to get the coordinates right, இப்போ இந்த டேபிள் நம்ம கிட்ட இருந்தா வச்சுக்கோங்க, solving this question is very easy, right? And இப்போ say for example we are trying to generalize this வச்சுக்கோங்க. Generalize and let's say for example all these masses are equal, m1 m2 m3 m4 m5 m6 m7 m8 எல்லா masses நம்ம ஈக்குவல் எடுத்தா which is equal to m, which is equal to what? m. இப்போ பாருங்க the center of mass ஓட x coordinate எப்படி? m1 x1 plus m2 x2 plus m3 x3 அப்படிதானா? We have to multiply up to m8 x8 divided by m1 plus m2 plus m3 அந்த மாதிரி up to m8. இங்க பாருங்க எத்தனை particles இருக்கா? 8 particles, right? Each of them we are saying equal in mass. So total mass எவ்வளவு? If you add up all the particles of the mass, it is what? 8m. அவ்வளவுதானா? So இங்க பாருங்க each of the masses we are taking it as what? Equal. நம்ம equal ஆன எடுத்தா equal இல்லைன்னு வச்சுக்கோங்க, then we have to use that same formula m1 x1 plus m2 x2 அந்த formula தான் நம்ம யூஸ் பண்ணணும். equal ஆன எடுத்தா வச்சுக்கோங்க, இங்க பாருங்க m1 x1 is anyway 0, இது வரும் m into a. ஓகேவா? அந்த மாதிரி இங்க என்னது m into a வரும். இங்க பாருங்க 0 0, இது என்னது m into a. இங்க என்ன வரும்? m into a வரும். ஓகேவா? லாஸ்ட் டேர்ம் 0 divided by total mass எவ்வளவு? 8m. நியூமரேட்டர் என்ன? 4 times வருது m into a, that is 4 times m into a divided by 8m. So பாருங்க what is it? mm cancel ஆயிடும். 4 by 8 என்ன? half தானா? So it is what? a by 2. So the center of mass ஓட x coordinate what is it? a by 2. ஓகேவா? இதெல்லாம் symmetrical தானா? இப்போ நீங்க பாருங்க you can check it. Y coordinate of the center of mass, that also will come as a by 2. வேணும்னு செக் பண்ணி பார்க்கலாம். what is it? இங்க அப்படிதானா? so m into a 2 times வருது, அதுக்கப்புறம் m into a 4 times. so y center of mass எவ்வளவு? 4 times m into a divided by total mass என்னது? 8m. அதையும் a by 2 தான். அந்த மாதிரி z coordinate of center of mass, that also will be what? a by 2. ஓகேவா? so இப்படி like you can have either 2 coordinates அந்த மாதிரி, or you can have like இந்த மாதிரி spatial distribution கொடுத்துட்டு they can give us questions. but இந்த மாதிரி ஒரு questions என்ன தெரியுமா? it's a straightforward thing. you have to first look at the coordinates பார்த்துட்டு we have to go for as per the weighted average formula. அவ்வளவுதான். ஓகேவா? it's a straightforward question. இதுல மிஸ்டேக் பண்றதுக்கு ஒரே ஒரு சான்ஸ் என்னன்னா if we make a mistake in identifying the coordinates of the particles, அதில் நம்ம கொஞ்சம் கேர்ஃபுல்லா இருக்கணும். ஓகேவா? so this is about finding the center of mass location for discrete particles when they are giving us the coordinates. when they are giving us இப்போ நம்ம சால்வ் பண்ண ப்ராப்ளம்ஸ் என்னன்னா they are giving us what is the xyz axis system. but in some cases என்னன்னா they will not give us what is the coordinate itself, what is the origin, அது ஒண்ணு கொடுக்காம they will ask questions like this. பாருங்க, 2 particles with masses 2 kg and 8 kg, 2 particles with masses 2 kg and 8 kg are at a distance 8 meters. பாருங்க, so there are 2 particles. So one is a 2 kg particle, other is an 8 kg particle. So what is the distance between them? 8 meters. Okay, wow. What is the distance of center of mass from the 2 kg particle? So 2 kg particle and what is the distance of the center of mass? இப்போ இதுக்கு முன்னாடி நம்ம சால்வ் பண்ண ப்ராப்ளம்ஸ்க்கு இதுக்கு டிஃபரன்ஸ் என்ன தெரியுமா? Here they are not even telling us what is the origin. ஏன்னா origin நமக்கு தெரியணும். அந்த மாதிரி we should know the axis, right? அப்பதான் நம்ம அந்த center of mass weighted average formula யூஸ் பண்ண முடியும். See, என்ன கேக்குறாங்க? They are asking what is the distance of the center of mass from 2 kg. அப்போ first நமக்கு என்ன தெரியணும்? We should know what is center of mass or location. Location னு சொன்னா we should know what are the coordinates. அதுக்கு we should first of all know what are the coordinates of the 2 points. அப்போதானே we will be able to find out the center of mass location. So இப்படி ஒரு ப்ராப்ளம் என்ன வெச்சுக்கோங்க. Then what we need to do is we can simply assume an origin and a coordinate axis. We have the freedom to do it. Okay, but இதில என்ன தெரியுமா? We should assume in such a way that the problem will be very simple to solve. இங்க பாருங்க, they are asking us what is the distance of the center of mass from the 2 kg particle. 2 kg particle and they are asking the distance. அப்ப என்ன தெரியுமா? I will take the 2 kg particle itself as the origin. ஏன்னா அவங்க என்ன கேக்குறாங்க? They are asking what is the distance of the center of mass from 2 kg particle, right? So அதனால என்ன, I will take the 2 kg particle as the origin. And 2 kg 8 kg நடுவுல what is the distance? 8 meters. So இப்ப பாருங்க, the line on which the 2 kg 8 kg, take it as the x-axis. இப்போ பாருங்க, what will be the coordinates of 2 kg location? 0, 0. And now we are taking it as what? Origin. What will be the coordinates of the 8 kg? So இது நம்ம x-axis எடுக்கிறோம், அதுதானா? So which will be what? Distance is 8 meters. Origin லந்து we are moving 8 meters along the x-axis, means x coordinate is 8 meter. X-axis மேல இருந்தா y coordinate is 0, z coordinate is also 0. So இங்க என்ன, வெறும் x coordinate location மட்டும் தான் வரும், y coordinate வராது, z coordinate வராது. ஓகேவா? So இப்போ பாருங்க, we will try to find what is the center of mass ஓட location. Location னு சொன்னா வெறும் x coordinate value மட்டும் தான். So பாருங்க, what is the center of mass location? என்ன வரும்? m1 into x1, 2 into 0, plus m2 into x2, 8 kg into 8 meters, divided by m1 plus m2. m1 plus m2 means what? 2 plus 8 எவ்வளவு? 10. So பாருங்க, numerator என்ன இருக்கா? இது 0. 8 8s are 64. Okay, so 64 by 10, what is it? 6.4. Okay, wow. So what is the center of mass oda x coordinate? 6.4. Okay, பாருங்க. So எங்க வரும்? It will be coming. So this is the point PM சொல்லலாம், or we can say center of mass point. Okay, wow. So what is the location? 6.4 meters. So question what is it that we need to find? What is the distance of the center of mass from the 2 kg particle? 2 kg particle means what? Origin dana. So origin la what is the distance of the center of mass? Enadhi? So distance of center of mass from 2 kg. What is the answer? 6.4 meters. So இந்த மாதிரி questions வந்து வெச்சுக்கோங்க. What is it? நம்ம தான் assume பண்ணனும். ஒரு பாயிண்ட் நம்ம தான் ஆரிஜினா எடுத்துட்டு அங்க இருந்து we have to look at what is the x coordinate, what is the y coordinate, what is the z coordinate. ஓகேவா? So this is a very simple situation. Two particles இருந்தா we will take them to be like on the x axis. Okay, so அதுல இருந்து we will be able to find out generally என்ன தெரியுமா, இந்த மாதிரி questions they will be asking us, ஏனா அவங்கள coordinate system அவங்களுக்கு கொடுக்கல, so they will be asking us the distance. So என்ன find out பண்ண கேக்குறாங்க? They will be asking us what is the distance. Okay, so இதுக்கு என்ன பண்ணனும்? First we should coordinate axis நம்ம எடுக்கணும். எடுத்துட்டு அதுல இருந்து we will get the center of mass location ஓட coordinates. வந்ததுக்கு அப்புறம் we will be able to talk about what is the distance of the center of mass from any given point. Okay, so பாருங்க, we will look at one more question. 3 particles masses 1 kg, 2 kg, 3 kg are placed at the corners A, B, C respectively of an equilateral triangle ABC. Edge length எவ்வளவு? 1 meter. So எங்க நம்ம points place பண்றது? on the corners of the equilateral triangle ABC. Okay va? Find the distance of the center of mass from A. So ipo parunga choice namakku irukha. We have to choose the origin, we have to choose the x axis, y axis ella. So we have to find what is the distance of the center of mass from point A. Adana enna, we will take the point A as the origin. Adu nama origin edukka porom. Okay, and the triangle, we will take the triangle to be in the xy plane. Xy plane kulla irukra maadhiri we will take the equilateral triangle to be where? On that xy plane. Ipo parunga. So this is our A, idu nama B edukala, idu enna C. Ipo parunga one side like appo base irukku theriyuma, adu nama x axis edukala. Andha maadhiri indha pakka parunga, idu y axis. Okay, so we have to assume the in the maadhiri questions la they will not be giving us what are the coordinates, nama da assume panna. Okay va? So mass values namakku theriyum. What are the mass values? Particle A adoda mass enna 1 kg, particle B adoda mass enna 2 kg, particle C adoda mass enna 3 kg. Okay, so what is m1 plus m2 plus m3, what is it? 1 plus 2 plus 3 adoda 6 kgs. Okay va? What is m1 plus m2 plus m3? That is 6 kg. Ipo parunga, we have to use the weighted average formula, means namak ella points oda coordinates theriyum. So A is origin, right? So takkana we will be able to say what will be the coordinates, 0 comma 0. B parunga, B is on the x axis, and what is the side length of the equilateral triangle? Adanadi 1 meter. Okay, so what is this side length? 1 meter. So B oda coordinates enna theriyuma, it will be 1 meter comma 0. Coordinates of the point B paranga, it will be what? 1 meter comma 0. Okay va? So that is what the coordinates of the point B. Adukapram we should know what will be the coordinates of the point C. Point C or the coordinates namakku theriyum. Okay, so everybody, how do we find the coordinates of the points? Inga parunga, if you draw an altitude for an equilateral triangle, right? Altitude is same as median. Altitude is same as what? Median. And altitude bisects the opposite side. So which means total side length evala 1 meter. So this is half meter. So the x coordinate of that point C, half meter. Y coordinate paranga, what is the y coordinate? Altitude dana. What is the y coordinate of that point C? Altitude of the equilateral triangle. What is the y coordinate? And then it's the altitude of the equilateral triangle. Okay va? So what is the altitude of the equilateral triangle? So in an equilateral triangle, the altitude or the height h will be equal to what? Root 3a by 2. In an equilateral triangle etta, adala what is the altitude value? It will be what? Root 3 into a by 2, where a is the side length. Okay va? So what is the altitude? Root 3 into a by 2, where a is the side length. Inga parunga, what is the side length or the edge? 1 meter. So it will be what? Root 3 into 1 by 2, that is simply root 3 by 2 meters. Avladha. So we are having the we are having the x coordinate, y coordinate of all the particles. Ipo parunga, what is the remaining thing? X cm and so now what is it? m1 x1 1 into parunga, what is the particle A oda x coordinate? 0. Okay, so that is zero. Adukapram m2 into x2. So 2 kg particle x coordinate enna 1. So it will be what? 2 into 1, which is 2. Adukapram m3 into x3 parunga, which is what? 3 into half. m1 x1 plus m2 x2 plus m3 x3 divided by what? m1 plus m2 plus m3. What is it? 6. Parunga, what is it? 2 plus 3 by 2 means what? 1.5 dana. So total enna varudhu? 3.5. 2 plus 1.5 means 3.5 by 6. Multiply by 2 நம்ம பண்ணா என்ன வரும்? 7 by 12 வரும். ஓகேவா? So what is the x coordinate of the center of mass location? 7 by 12 meters. Okay va? Adukapram we can find what is the y coordinate. Okay, what is the x coordinate of the center of mass location? 7 by 12 meters. So we'll keep it at the top. Center of mass x coordinate 7 by 12 meters. Okay. Ipo parunga, what will be the y coordinate? Center of mass or y coordinate enadhi same formula, right? Y center of mass is equal to what? m1 y1 plus m2 y2 plus m3 y3 by total mass m1 plus m2 plus m3. Paranga, what is it? Y center of mass is enadhi m1 y1. So particle A oda y coordinate enna 0. So அந்த term வராது. அதே மாதிரி m2 y2 particle B oda y coordinate is also what? 0. அந்த term வராது. Where we will get m3 y3 மட்டும் வரும். So m3 is what? 3 into y3 is what? Root 3 by 2 divided by m1 plus m2 plus m3 means what? 6. அவ்வளவுதானா? 3 2s are. So what is it? Root 3 by 4 meters. So either y center of mass. But question enna, they are not asking us what is the coordinates. Enna avangale coordinates பத்தி மென்ஷனே பண்ணல. They are not giving us the coordinates. What they are asking us, they are asking us what is the distance of the center of mass from the corner A. So corner A la irundhu what is the distance of the center of mass. இப்போ பாருங்க, ஏன் நம்ம first of all why we have chosen corner A as the origin தெரியுமா? Because finally நம்ம என்ன calculate பண்ணனும்? We should calculate the distance of that center of mass point from the corner A. So corner is the origin, right? If you have any point with coordinates like this one, x center of mass comma y center of mass, what will be the distance of the point from origin? Root of x center of mass square plus y center of mass square. So if you have a point with coordinates x comma y, what is the distance from origin? Root of x square plus y square. If you have a point with coordinates x comma y comma z, what is the distance of the point from the origin? And it will be root of x square plus y square plus z square. So paranga, what is it? Distance from the mass A to the center of mass, then is the root of xcm square, which is 7 by 12 the square, which is what? 49 by 12 square means what? 144 dana, plus root 3 by 4 the square, which is what? 3 by 16. இப்போ பாருங்க, what is it? நம்ம சிம்பிளிஃபை பண்ணலாம். Okay, what is it? 49, நீங்க LCM எடுத்தேன்னு வெச்சுக்கோங்க, 140, 16 9s are 144. So common LCM of the denominator is what? 144 only. Okay va? So 16 9s are 144, right? So it will be what? 3 9s 27 varum. So 49 plus 27 evada? That is 76. So root 76 by 144. Okay, so now simplify. We can simplify it. Okay, we can see that 4 can be cancelled. We can just cancel the 4. Okay, that's why we simplify. So but this is the answer. What is it? D will be equal to what? Root 76 by 144. So like the other questions, they will be not giving us the coordinates. We have to take the origin. We have to find out what will be the coordinates of the center of mass. We will have to find the distance. Okay, so this is a very standard model of question. Question 4 particles of masses 1 kg, 2 kg, 3 kg, 4 kg are placed at the 4 vertices A, B, C, D. Square side length 1 meter. Find square of the distance of center of mass from A. Distance and kekla. So what is the little? We will ourselves make mistake in reading the question statement. Find the square of the distance of their center of mass from the point A. Okay, same approach dana. We will take the vertex A as the origin. Edutittu A, B, adukaprom C, all are at the corners of the square. D. What is the coordinate system we are going to choose? இது கொஞ்சம் சிம்பிளிஃபைடாக வரும். ஏன்னா இதுக்கு முன்னாடி நம்ம எடுத்த ப்ராப்ளம் என்ன, ஈக்குவலேட்டர் ஆங்கிள். ஸோ அதில் ஆல்டிடியூட் அது மாதிரி வருது, √3 terms. பட் இங்கே அப்படி கிடையாது. இங்கே பாருங்க. ஸோ the origin is taken as what, A. The line on which B is lying, that is the x-axis. The line on which D is lying, that is what we are taking as the y-axis. இப்படி நம்ம எடுத்தான்னு வச்சுக்கோங்க. Then the x coordinate of the A is 0, அந்த மாதிரி y coordinate is 0. Squared side length எவ்வளோ A ன்னு சொல்லலாம், that is 1 meter here given. Okay, so இப்போ பாருங்க, the coordinates of B will be what, 1, 0. It is on the x-axis. அந்த மாதிரி coordinates of D பாருங்க, it is on the y-axis. So it will be 0, 1. And the side length is what, 1 meter, right? இப்போ பாருங்க, what will be the coordinates of point C? We have to cover 1 meter along the x-axis. அந்த மாதிரி 1 meter along the y-axis, right? So it will be what, 1, 1. அவ்வளவுதான். So these are the coordinates. These are the coordinates. இது வச்சுட்டு we can calculate what is the center of mass oda location. So how do you calculate center of mass location? பாருங்க. So corner A, what is the mass? 1 kg. Corner B, what is the mass? 2 kg. Corner C la 3 kg. Corner 4 la 4 kg. Okay, so பாருங்க, what will be the center of mass x coordinate? m1 x1, 1 into 0, plus m2 into x2, 2 into 1, 2, plus m3 into x3, 3, plus m4 into x4, that is 0, divided by m1 plus m2 plus total நம்ம add பண்ண பாருங்க, 1 plus 2 plus 3, 6 ஆயிடுச்சு, plus 4, அதோட 10. So numerator 5 by 10, which is what, half. அந்த மாதிரி YCM பாருங்க, m1 y1 0, m2 y2, and இங்கேயும் y coordinate 0 தான், m3 y3, which is what, 3 into 1, 3 வரும், m4 y4, which is what, 4, divided by 10, what is it, 7 by 10. Okay va? So previously என்ன 5 by 10, which is half. இப்போ அது 7 by 10. So வேணும்னா we can just leave it like this only, 5 by 10. So what is the square of the distance of the center of mass from the mass A? Mass A na origin dana. So what is the square of the distance? D is what, root of x centimeters center of mass square plus y center of mass square. D square means what, x center of mass square plus y center of mass square. அவ்வளவுதானா? So square of the distance from the vertex A to the center of mass will be what, x center of mass square plus y center of mass square, which is what, 5 by 10 the square plus 7 by 10 the square. என்ன பாருங்க, 5 square means what, 25, 10 square means what, 100. அந்த மாதிரி இங்க பாருங்க, 7 square is 49. So total என்ன வரும், 25 plus 49 by 100. What is 25 plus 49? What is it? It will be 74 dana. So 74 by 100. So d square value என்ன வருது, it's coming as what, 74 by 100. வேணும்னா நம்ம simplify பண்ணலாம். ஓகேவா? So this is about how do we approach the questions on finding the distance of the center of mass from a given point. ஒரு given point ல இருந்து how do we calculate the distance of the center of mass. இந்த மாதிரி questions என்ன தெரியுமா, like they will not be giving us what are the coordinates of the points. நம்ம தான் assume பண்ணணும். Okay, நம்ம assume பண்ணிட்டு அதுல இருந்து we will have to derive the coordinates of the center of mass location. அதுக்கப்புறம் we will be able to find the distance they are asking. ஓகேவா? So this is another type of question. Either அவங்களே அந்த coordinates எல்லாம் கொடுத்துட்டு they will be asking us to find what is the coordinates of the center of mass. அது ஒரு மாடல். செகண்ட் மாடல் என்ன, அப்படி coordinates கொடுக்காம they will be giving us the points. நம்ம தான் assume பண்ணணும். நம்ம assume பண்ணிட்டு அதுல இருந்து இங்க என்ன தெரியுமா, they will not be asking us the coordinates. ஏன்னா அவங்களே coordinates பத்தி மென்ஷன் பண்ணல. இங்க என்ன, they will be asking us about the distances. So first நம்ம coordinates calculate பண்ணணும். அந்த coordinates வச்சுட்டு we have to find the distance. இந்த மாதிரி questions என்ன, two step process. ஓகேவா? So this is about the center of mass of the discrete system of particles by using the weighted average formula. Okay, So when you look at the understanding that we are getting by solving some problems, right? In solve பண்ண problems வந்து we are able to get some clarity. இப்போ பாருங்க அந்த நம்ம solve பண்ண problem என்ன? So first one, right, where we have the 2 kg particle and 8 kg particle. We solved it. We took the particles to be on the x-axis. அப்படிதானா? So we took the particle to be on the, both of them to be on the x-axis. Where we got the center of mass? We got the center of mass also on the x-axis. Center of mass is also coming on the x-axis. Okay, so remember what is the center of mass value we got? We got it as what? 6.4 meters only. Okay, so the coordinates of the 2 kg are 0, 0 because that is the origin we took. Okay, other origin 8 kg coordinates are what? 8 meters, 0. So center of mass will be only on the x-axis. So if you have center of mass of 2 particles, then where it will lie? It will lie on the straight line joining the 2 particles. So இப்போ 2 particles எடுத்து வெச்சுக்கோங்க, 2 kg 8 kg. அதோட center of mass எங்க வரும்? It will be on the line joining the 2 masses in between the 2. பாருங்க, so எங்க வருது? It will be on the line joining the 2 masses in between the 2. Okay, not exactly the middle point. எப்போ தெரியுமா? When it will be middle point? When both the mass are equal. ரெண்டு masses equal இருந்தா then it will be at the middle point. But எங்க வரும்? It will be on the line joining in between the 2 particles தான் வரும். நம்ம அந்த எக்ஸாம்பிள்ல பார்த்த மாதிரி. So where it is going to be? It is going to be on the line joining in between the 2 particles. And நீங்க position observe பண்ணா we will be able to understand one thing. It will be, so இப்போ center of mass ஓட distance பாருங்க. இந்த பக்கம் எவ்வளவு? What is the distance here from the 2 kg? 6.4 meters. இந்த சைடுல what is the distance? And a total 2 kg 8 kg nodal, what is the distance? 8 meters, right? So இது நம்ம 6.4 and சொன்னா, what is the other side? Other side எவ்வளவு வரும்? It will be 1.6 meters தானா? And the total distance is 8 meters. So பாருங்க, the center of mass of the particles, right, is located near to the heavier particle. பாருங்க, so 2 kg இருக்கு, 8 kg இருக்கா, அதுல எது heavier particle? 8 kg தானா? So center of mass is lying closer to the heavier particle. Okay, so இப்போ நம்ம ரெண்டு particle system எடுத்தா center of mass will be எங்க இருக்கும்? It will be on the line joining in between the 2, but the center of mass will be more closer to the heavier particle. Okay, so நான் சொன்ன மாதிரி if both the particles are equal mass னு வெச்சுக்கோங்க, if both the particles are equal masses, அப்ப என்ன ஆகும்? Then the center of mass னு சொல்லலாம், or we will generally refer to as point P. அப்படி ஏன்னா நம்ம டிஸ்கஷன்ல நமக்கு அந்த பாயிண்ட் நம்ம மென்ஷன் பண்ணோம். ஓகே, so center of mass or the location of point P that we are discussing, that will be at the midpoint. எப்போ? when both these masses are equal, apparently they will be having the center of mass exactly at the midpoint. But normally if they are having different masses means center of mass will be more closer to the heavier mass. Okay va? So this is about some of the things that we are able to understand by solving some problems. Okay, if we look at the center of mass position in the vector form, and what is it that we saw? Tanitaniya coordinates, x center of mass, y center of mass, z center of mass. So same we will take for 2 particles in vechukonga. X center of mass formula enna? m1x1 plus m2x2 by m1 plus m2. Adana. What is the y center of mass? m1y1 plus m2y2 by m1 plus m2. What is the z center of mass? m1z1 plus m2z2 by m1 plus m2. Idana. அப்படியே நீங்க position vector நமக்கு வேணும் வெச்சுக்கோங்க. Position vector center of mass. What is the position vector of any particle? By the particle x coordinate into I cap plus y coordinate into j cap plus z coordinate into k cap. அதுதானா? So பாருங்க, we are having a point with x, y, z coordinates. What is the position vector? xi cap plus yj cap plus zk cap. அதுதானா? So center of mass ஓட position vector அது என்ன வரும் பாருங்க? x center of mass into I cap plus y center of mass into j cap plus z center of mass into k cap. அப்படி இந்த வேல்யூஸ் எடுத்துட்டு let us just go and substitute. பாருங்க x center of mass ன்னு சொன்னா what is it? m1x1 plus m2x2 into I by m1 plus m2. அடுத்து என்ன? m1y1 plus m2y2 by m1 plus m2 into j. அடுத்த term என்ன வரும்? m1z1 plus m2z2 by m1 plus m2 into k. ஓகேவா? ஸோ அதுதான் the expression. இப்போ நம்ம simplify பண்ண போறோம். அதுதான் the expression for what? The position of the center of mass, position vector of the center of mass. ஓகேவா? இப்போ பாருங்க அது எப்படி simplify ஆகும். எல்லாத்துலயும் denominator காமன் தானா? m1 plus m2. மூணு டேர்ம்ஸ்ல denominator காமன் m1 plus m2. ஸோ அப்படி நம்ம காமனா எடுக்கலாம். what is it? m1 plus m2 காமனா நம்ம எடுத்தா what is it? இங்க பாருங்க m1x1 into y. செகண்ட் டேர்ம்ல இருந்து m1y1 into j வருது. தேர்ட் டேர்ம்ல இருந்து m1z1 into k. அப்படியே நம்ம அந்த m1 மட்டும் காமன் எடுத்து வச்சுக்கோங்க. what is it? x1i plus y1j plus z1k. அந்த மாதிரி இங்க பாருங்க ஃபர்ஸ்ட் டேர்ம்ல we have m2x2i, செகண்ட் டேர்ம்ல m2y2j, தேர்ட் டேர்ம்ல m2z2k. அதுல இருந்து we'll take m2 காமன் எடுத்தா x2i plus y2j plus z2k. What is this x1i plus y1j plus z1k? அதாவது the position vector of the first particle தானா? ஸோ அது நம்ம r1 bar அப்படி நம்ம ரெப்ரசென்ட் பண்ணலாம். What is x2i plus y2j plus z2k? அதாவது the position vector of particle 2 தானா? So what is it? We can write like what? m2 into r2 bar divided by m1 plus m2. So இதுதான். This is what is the formula for the position vector. நம்ம position vector கொடுத்தேன்னு வச்சுக்கோங்க. How do we calculate the, instead of giving the exact அந்த தனித்தனியா location கொடுக்காம they are giving us the position vectors. Let's say for example two particles are there. First particular position vector is this, second particle position vector is this, like that. அப்படி கொடுத்தேன்னு வச்சுக்கோங்க. What do we need to do? We will have to use this formula. What is the r bar cm? It is coming from the same and the discrete. நமக்கு தனித்தனியா x coordinate தனியா y coordinate தனியா அப்படி எழுதாம we are writing all of them together by using the position vectors. So what is the formula? R bar center of mass is equal to what? m1 r1 bar plus m2 r2 bar plus m3 r3 bar. அப்படி like whatever number that is there, divide by m1 plus m2 plus m3. இங்கேயும் அந்த மாதிரி தான். என்ன தெரியுமா? What is it? It is the weighted average. So the position vector of the center of mass, right, is given by what? It is given by the weighted average of position vectors of particles. It is given by the weighted average of position vector of particles. And what is the basis for the weightage? எது நம்ம weightage எடுக்கிறோம்? The mass of each particle. Okay va? So m1 r1 plus m2 r2 அப்படி whatever number that is there. Let's say for example we are having 4 particles வச்சுக்கோங்க. Then what will be the position vector of center of mass? m1 r1 bar plus m2 r2 bar plus m3 r3 bar plus m4 r4 bar, like 4 particles are there, divide by m1 plus m2 plus m3 plus m4 அப்படி வரும். 5 particles means இங்க ஒரு term add ஆகும், அவ்வளவுதான். Okay, so this is how we are going to find the position vector for the discrete particles of the consideration. Discrete particles சொன்னா what is it? Like we have countable number of separate particles. Okay va? So adala we will be able to find out the position vector of the center of mass by using this particular relation. Okay, so we will try to see some more terms related to that. When the position vector formula la, we are using this m1 r1 m2 r2 and the madri. Each of these terms, right, m1 r1 agatum or m2 r2, they are called as the moment of mass of the particle 1 and the madri moment of mass of particle 2, moment of mass of particle 3 about the origin of the coordinate system. m2 r2 will be what? The moment of mass of the particle 2 about the origin. So what is this, so in the மாதிரி நீங்க term பார்த்தானா don't think it is something different. Okay, moment of mass னா what is it? For any mass, right, the mass of the particle times அதோட position vector. Okay, so position vector is taken with respect to what? With respect to the origin. எது நம்ம origin எடுத்திருக்கோம் அந்த originல இருந்து we have to calculate the position vector. Okay வா? So this is what is called as the moment of mass of each particle. Okay, m1 r1 bar is called as what? Moment of mass of particle 1. And the மாதிரி m2 r2 is called as what? Moment of mass of particle 2. Okay va? So அடுத்த point பாருங்க, this is a very important one. Okay, ஏன்னா what we think is, okay, see நம்ம origin ல இருந்து we are trying to give the position vectors, right? r1 ஆகட்டும் or r2 ஆகட்டும் or r3 for different particles. Okay, m1, m2 is here and m3 is here. When we use this formula, what is the formula we are going to use? RCM is equal to m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3. Okay va? That's the center of mass. Let's say center of mass location or point P in எடுத்துக்கோங்க. That is center of mass location. Okay, இப்போ என்னன்னா the idea that we will have is this r1 bar r2 bar, they are taken from the origin. Okay, and origin nama change பண்ணல, origin nama change பண்ணல, like so like in the problems we solved, right, nama solve பண்ண problems la we were choosing the origin, right? Like we said what 2 kg particle location is the origin, or the and the equilateral angle case la we took the corner A as the origin, அப்படிதானா? Like that we were taking, right? So இப்போ நம்ம அந்த origin oda selection நம்ம change பண்ணா what is going to happen to the location of the center of mass? இது ஒரு doubt. and இப்போ பாருங்க இந்த formula what is it? The position vector of center of mass is depending upon what? r1 r2 r3 r4. நம்ம origin change பண்ண வெச்சுக்கோங்க, r1 value change ஆகும். இப்போ இதுக்கு பதிலா let's say for example we are saying we are shifting the origin, எங்கல இருந்து shift பண்ணிட்டு we are saying this is our origin, இது நம்ம new origin. அப்படி நம்ம origin shift பண்ண வெச்சுக்கோங்க, அப்ப என்ன ஆகும்? இங்க பாருங்க, அங்கல இருந்து we have to give the position vectors, right? That is going to be our new r1, this is going to be our new r2 r3 அப்படி. so ஏன்னா நம்ம origin change பண்ணா the position vector actual vector values will be changing. அப்ப என்ன ஆகும்? the r center of mass value will be changing. ஏன்னா because the r center of mass will be again, it is going to be based on, this is the r center of mass, right? This is going to be based on the new origin. New origin la நம்ம position vector define பண்ண மாதிரி வரும். but geometric location, இப்போ பாருங்க எங்க அந்த center of mass இருக்கோ அதோட geometric location change ஆகாது. ஆமா, value wise அந்த position vector ஓட value change ஆகல, ஏன்னா position vector depends upon the origin. நம்ம எங்க நம்ம origin எடுக்கிறோம் அது பேஸ் பண்ணி தான் position vector ஓட value வரும். but the geometric location of the center of mass அது change ஆகாது. so இது ரொம்ப important point. என்ன பாருங்க, the geometric location of the center of mass which we are taking at a point P does not depend upon the choice of the coordinate system. Choice of the coordinate system anu sonna enadhu, where we take the origin, which is our x axis direction, which is our y axis, and the which is our z axis. Okay va? so ipo nama normally நம்ம கிட்ட ஒரு origin எடுக்க, அது எடுத்துட்டு we have shifted the origin to some other point. so even if we select any other point as the origin, right, the geometric location will be coming as same. Geometric location will not be changing, but enagala the actual position vector value can be changing. Okay, so for 2 particles agatum or 3 particles, whatever be the number, the geometric location, actual location change agadu, but position vector value might change. Yeah, the position vector, right, value is dependent upon what is the origin, but location change agadu. Okay va? so this is a very important point about the what happens to the location of center of mass. In the madri theoretical questions varala, like they can say if the origin of the coordinate system is changed, what is going to happen to the center of mass location? Center of mass location change agadu, location agada irukum, geometry location change agadu. Okay, maybe the value of the position vector might change, the position vector value will depend upon the coordinate system choice, right? Okay va? so அடுத்து பாருங்க, this is like a derived point. எடுத்த பாயிண்ட்ல இருந்து ஒரு derived point மாதிரி தான். ஓகே, so இங்க பாருங்க, what is this particular statement telling us? If the origin O of the coordinate system is shifted to the center of mass. So origin நம்ம we can shift it to any point, right? இங்க பாருங்க, so we are having two masses, m1 இங்க இருக்கு, m2 இங்க இருக்கு. ஓகேவா? so இது நம்மளோட normal origin. so this is our r1 bar, அதே மாதிரி this is our r2 bar. okay, so what is the r center of mass? m1 r1 plus m2 r2 by m1 plus m2 இதானா? that is the position vector center of mass. அது எங்க இங்க வருது? p. okay, இப்போ என்னன்னா we are saying let us shift the origin. எங்க நம்ம shift பண்ண போறோம்? we are going to shift the origin to the point p itself. இங்கல இருந்து எடுத்துட்டு we will shift the origin to the point p itself. அது நம்ம o dash னு சொல்லலாம். அங்க நம்ம shift பண்ண வெச்சுக்கோங்க. then பாருங்க, this is our r1 now. நம்ம ஆரிஜின்ல இருந்து நம்ம பொசிஷன் வெக்டர் டிஃபைன் பண்ணோம். இது என்னது? r2. when you want to give the center of mass position vector, what is the formula? இப்போ புது r1 வர r2 வேல்யூ m1 r1 plus m2 r2 by m1 plus m2. பட் பாருங்க, what is this? position vector of center of mass. but center of mass எங்க இருக்கா? that is our origin, right? so which means this should be 0 தானா? நம்ம origin எடுத்துட்டு we are shifting it to what? the center of mass location. அப்படி shift பண்ணா that m1 r1 plus m2 r2, right? அதோட value should be coming as what? 0. ஏன்னா because center of mass ஓட position vector will be what? 0, right? because we are shifting the origin itself to the center of mass. அப்படி நம்ம shift பண்ணா then the m1 r1 plus m2 r2 இங்க என்னன்னா r1 r2 are the position vectors with respect to origin. but என்னன்னா இங்க நம்ம எடுத்த origin என்னது? that is the center of mass point. ஓகேவா? so this is another standard result. this can be used in some questions. இந்த result பத்தி நீங்க ஞாபகம் வச்சுக்கோங்க. ஏன் இந்த result வருது? because when we take the center of mass itself as the origin, right? and the r bar cm formula நம்ம போட்டா what is it that we are going to get? r bar cm should be 0. ஏன்னா the origin itself is our center of mass. so அங்கிருந்து we will get this result. what is it? m1 r1 plus m2 r2. அப்படியே like you are having 3 particles வச்சுக்கோங்க. what is going to happen? m1 r1 plus m2 r2 plus m3 r3 அந்த மாதிரி 3 வரும். 4 particles சொன்னா m1 r1 plus m2 r2 plus m3 r3 plus m4 r4 அப்படியே வந்துட்டே இருக்கும். ஓகேவா? so this is about the relation between position vectors of the particles of the system when we take the origin itself as the center of mass. ஓகேவா? so the last question பாருங்க. the position vector of 3 particles m1 கொடுத்திருக்காங்க, m2 இருக்கா, m3 இருக்கா. they are giving us r1 r2 r3. find the position vector of the center of mass. அவ்வளவுதானா? what is the rcm? m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3. இங்க என்னன்னா first நம்ம அந்த m1 plus m2 plus m3 அப்படியே we'll just take it out separately. what is m1 plus m2 plus m3? 1 plus 2 plus 3 எவ்வளவு? 6. so அப்படியே அது 1/6 நம்ம தனியா எழுதலாம். ஓகேவா? இப்போ பாருங்க m1 r1. so ஒரு நம்ம வேல்யூ எடுத்துட்டு இங்க பாருங்க. so m1 r1 means what? 1 into I plus 4j plus k. that is what? I plus 4j plus k. அது சேஞ்ச் ஆகாது. அதுக்கப்புறம் m2 into r2 means 2 வச்சு நம்ம இந்த r2 மல்டிப்ளை பண்ணணும். so மல்டிப்ளை பண்ண என்ன வரும் பாருங்க? 2i வரும், அதுக்கப்புறம் 2j வரும், அதுக்கப்புறம் 2k வரும். அந்த மாதிரி m3 into r3 means 3 வச்சு நம்ம அந்த r3 மல்டிப்ளை பண்ணணும். மல்டிப்ளை பண்ண என்ன வரும் பாருங்க? 6i minus 3j minus 6k. that is our m3 into r3. so எல்லாம் நம்ம 3 ஆட் பண்ணதானா? so m1 r1 plus m2 r2 plus m3 r3 ஆட் பண்ண என்ன வரும் பாருங்க? இங்க என்னது? i, அதுக்கப்புறம் 2i, அதுக்கப்புறம் 6i. டோட்டல் எவ்வளவு? 9i. அந்த மாதிரி இங்க பாருங்க 4j 2j 6j minus 3j means இங்க பாருங்க k plus 2k எவ்வளவு? 3k. 3k minus 6k means minus 3k. Okay, so பாருங்க, what is it? அப்படி நம்ம உள்ள எடுத்து போய் நம்ம டிவைட் பண்ணா what you are going to get 9/6 into I வரும், 3/6 into J வரும், minus 3/6 into K வரும். What is 9/6 into I means? 3/2 I. 3/6 into J means half J, minus 3/6 into K means half K. அவ்வளவுதான். So what is the position vector of center of mass? 3/2 I plus half J minus half K. Okay va? So this is the first segment. What is it? Finding the center of mass of discrete system of particles. அடுத்த கிளாஸ்ல என்ன, we will start with how do we find the center of mass of the extended body, continuous object and சொல்லலாம், or the extended body, right? அதோட center of mass எப்படி நம்ம calculate பண்ண போறது, that is what we will start in the next class. Okay va? We will see in the next class.